from the last video, Caleb introduced us to the integral of the volume of the solid. Depending on whether this is a vertical or a horizontal axis of rotation, we can determine whether it's in respect to x or y. Whenever we have a vertical axis of rotation, it will always be in respect to x, while the horizontal axis of rotation will always be in respect to y. First, we have a general representation of the vertical axis of rotation. The p of x is the average radius, or the distance between the axis of rotation and the center of the rectangle or shell. The h of x is the height of the rectangle or shell. After we have all of this down, let's try a problem. Consider the region enclosed by the curves y equals to x cubed plus x equals to 2, and the x-axis. Rotate the region about the x-axis and find the resulting volume. So here's a graph with all of the functions. Since we have the vertical axis of rotation, we have it in respect to x. Now we have to find the p of x and the h of x from this integral that we were given earlier on. So we know that p of x is the average radius, or basically just for the distance between the axis of rotation and the center of the rectangle. And we'll just call this x since this function or this problem is in respect to x. And then we have the height right here, h of x. And as you can see, the rectangle touches the function, which means that the height would be x cubed plus x, the function. And finally, we have the thickness of the rectangle, which is just the change in x, or dx. But wait, we also have, one more thing to remember, the upper and lower limits. So as you can see from this graph, that the lower limit for x is 0, and the upper limit would be 2. So after we have all of these down, we have the integral that's set up. And just to simplify this integral, this would be the integral that we would use to integrate, which is the volume equals to 2 pi times the integral of x to the 4th plus x squared dx from the limits of 0 to 2. And so now that we have everything set up, we can start to integrate. This is already integrated for you because I expect you guys to know how to integrate, or else expect a 1 on that test that you just took on May 15th.